Okay, friends, here we go. What are we ready for? Are you ready to find the slope? All right, here we go. We are going to, we're ready for number 2, I think. So we're going to find the slope. All right, this is easy. You've been doing it for years. How do you find the slope? Oh, help. Our points are -1, -2, and 3, 4. What's our slope going to be? 4 minus -2, 3 minus -1, 6 over 4, yep, 3/2, beautiful. How about the second one? Yeah, we got a little bit of a problem with the second one, because when we try to find the slope, we end up with a 0 in the bottom, which means our line, or our slope is undefined, but what does that tell me about my line? What kind of line do I have if the slope is undefined? What? X equals vertical. It's a vertical line. That would be the line x equals 5, right? Okay. Number 3. If the slope of AB is -7/5, and A is this point, and B is this point, find x. We know the slope is -7/5. All right, anybody have a plan for that? Oh, I think you do. What would the slope be here? Can we just find the slope here? The slope of AB would be 4 minus 3 over x minus 6, right? But they tell me that the slope is -7/5. So doesn't y minus y over x minus x has to equal -7/5? How do I solve something like that? Cross multiply? I would probably go ahead and make this a 1, just to simplify my life a little bit. And now I'll cross multiply, so 5 equals -7x plus 42. Keep an eye on my arithmetic. So -47 equals -7x. I got 47/7 for my x coordinate. Did I make a mistake? Avery, you're looking at kind of funny. Did I make a mistake?
Well, minus 42.
Yeah, so that would not be 47, that would be 37, right? Thank you. That's why you were looking at it funny. I was wrong. Is it better now? Thank you. Okay, number 4, write the point slope form of the line through these 2 points. Anybody know what point slope form is? You guys always fake me out. I know you know, you just won't tell me. What is the point slope form of the line? What? Now, y equals mx plus b is a form of a line. It isn't point slope though. It is what? Slope intercept. So y equals mx plus b looks like it's going to be another one of our questions. But y equals mx plus b, that is your slope intercept form. And it's called slope-intercept because in the equation, you have the slope and the y-intercept. Great form, very useful, but it's not point slope. Anybody have another idea?
Y minus y equals m, x minus x.
Exactly, yeah. Even if you think you've never seen that before, you have, because look what happens. If I divide by that parentheses, I get m by itself. What will m end up equaling? If I divide this over, m equals what? Y minus y over x minus x. That's just the slope formula with the fraction gotten rid of. Okay, so here we go. Oh wait. What am I gonna need to do first? Find the slope. So step one, we're gonna find the slope. All right, I got -3/4. Does that seem right? Come on now, you don't have error prone, all right? Now, that's m. This is one of your points. Doesn't make any difference which one, so which point do you want to use? Doesn't make any difference, pick one.
First one.
First one, there we go. So y minus 7, this is your point. You pick this one. So y minus 7 equals -3/4 x plus 2. And that is the point slope formula line. Now, I think it's reasonable to think about, well, wait, Mrs. Ford, you told me I could use either point, but clearly if I use the other point, that one right there, my equation looks very different, doesn't it? They're both okay, and actually they are the same line. If you got y by itself, here and here, they match. They have the same slope intercept form. So it doesn't matter which one, which point you use. That's point slope form and you're done. That's it. Write the standard form of the line. Okay, so we talked about slope intercept. We talked about point slope. What do we mean by the standard form of line?
Ax plus by equals c.
Exactly. So we're gonna write a line, and in the end, it's gonna look like that. It's gonna look like 7x minus 2y equals 9. It's gonna have that form when we're done. Here's the good news. We're gonna start exactly the same way. So my points are 6, 2, and 7, -3. I'm gonna find the slope like I always find the slope. So slope is gonna be what? 2 minus -3 over, oh, this one works out nice. Wait, did you get -5? Okay, now I'm gonna pick a point. Doesn't matter which point, I'm just gonna pick one. Is that right, if I use that one? So y minus 2 equals -5, x minus 6. What's that called right there? Point slope. And if the direction said point slope, I'd be done. But they don't. They say standard form. So guess what I'm gonna do? I'm just gonna do whatever math I need to do to make my equation look like this. So I'll probably start by distributing. And then I need that x and y to be on the same side. So I'll add this over. Ditch the 2 to the other side. And there is your standard.
I'm just double checking, you can't have a negative first, right? Like if it was a -5, you'd have to divide it
There are kind of very formal rules for that, and generally speaking, we don't like to have a negative here, so we like to make that positive. That's easy to fix. We also prefer, if at all possible, not to have any fractions. So then you would have to clear out the fractions by multiplying by the common denominator, right? Standard form, quite honestly, is not used very much. I mean, equations will be given to you in that form, but they're not really very usable in that form, so we usually change them into something else. But yeah, you're right. You're right. Good? All right. Repeat for these 2 points and find the slope-intercept form. Now, this is one where you could certainly do this differently than I'm going to, but I have limited brain capacity, and I'm going to do every problem the same way, and then fix the form. So I'm going to go ahead and find my slope. Which is what? 6 3/5? Make sure I got that right. Then I'll pick a point. I'll just pick this one. So y minus 4 equals 3/5 x minus 8. And again, what's that? One slope. If I need slope-intercept, I need to get my y by itself. So y minus 4 equals 3/5 x minus 24/5. Now add 4. So I got 3/5 x minus 4/5. I don't know if that's right or not. I'll let one of you tell me if it is or not. Okay, so again, I don't care how you do the problem, it's completely up to you. Just answer in the form you're supposed to answer. Okay, easy. All right, what's next? Write an equation for the line containing this point and parallel to this line. It doesn't tell me how to write it, it just says write the equation of the line. Alright, so what's your thought on that? That's a pretty easy problem. Think about it for a second. What do you think? Yeah.
Just use the slope and then put it in point slope form. with the
So,
new points.
why would I just use the slope? And what is the slope, by the way?
It's 4, and it's because it's parallel, so it has the same slope.
So you all know what slope means, right? Rise over run. If lines are parallel, doesn't it make sense that their slope would be the same? So she says use 4 and that point. So y plus 2 equals 4 x minus 3. And since there aren't any directions, I can just stop. Now, if you want to do more, you absolutely could write this in another form, but we might as well just stop. How about number 8? Same exact thing, only this time we want the perpendicular. What changes when we want the perpendicular? Opposite and reciprocal. So the slope we're going to use is the opposite reciprocal of that one. So what is the opposite reciprocal of 4? Negative 1/4. I think it's the same point. So there it is. All right, that seems okay, right? Good. Number 9, given all these points, find A and B so the quadrilateral ABCD is a parallelogram. quadrilateral A, B, C, D, the points have to be connected in that order. So that actually helps us out here. I know that I have to connect A and B, and then I have to go to C, and back to D. So it's gotta look something like that. And I gotta figure out what point C is, basically, that's my job. I think you can do that. It really helps if these are on the x-axis like that. What do you think? What do you think that point is? 6.5. And Mr. Berg, you were the first one that I heard anyway. How did you get 6.5? What was your logic?
D is just 4 points to the right of it. So I just added 4 to the
These
x
have to be
value.
parallel, right? So if that one's straight across 4, is that one gonna be straight across 4? Perfect. Write the equation of the line tangent to this thing at the point -3, 4. What is x squared plus y squared equals 25? Circle. It's a circle with a center at the origin and a radius of 5. So, of course, it's not gonna look very circular, but there it is. And then somewhere on that circle is the point -3, 4. And I want to write the equation of the line tangent to the circle through that point. Okay, so do you understand what's going on? Okay. Write the equation of the line. I need 2 things to write the equation of a line. What do I need? Slope, point. I got the point. The point's -3, 4. I got that. So that's good. Now I need to find the slope of that line. Think about geometry. To find slope, don't I need 2 points? Right? And in this picture, I got 1 point. I also know another point. The other point I know is my center, right? I could find this slope. That's a radius of the circle. I could find that slope. So the slope of the radius would be 4 minus 0 over -3 minus 0, so -4/3. Do you agree with that? Now here's where geometry comes into play. What do you know about a radius and a tangent at the point of tangency? What's that relationship right there? They're perpendicular. So since we know the slope of our radius is -4/3, we know the slope of our tangent line is going to be 3/4. Y minus 4 equals 3/4 x plus 3. There's the equation of your now we got a couple word problems here. Actually, there's a lot of this, by the way, in our curriculum, where we have to take data and somehow come up with what we call a regression for it, an equation for it. So let's read through, what does this say? Okay, write a linear equation for spending in terms of year using the first 2 points in the table. Now, first of all, if we were to plot all those points, so there's 1, 2, 3, 4, 6 points. If I were to set up a graph and plot those 6 points, would they all lie in a perfectly straight line? No. Now, they might look linear. I mean, hopefully they would have some kind of, general relationship that way, but they're not all going to be on a perfect line. So they're telling you, and we're gonna get our calculators out, another calculator, but not yet. Write a linear equation for spending in terms of year using the first 2 points in the table. So the first 2 points in the table, so that would be like maybe those two points right there. We're going to use 1998, comma 5.9, and 1999, comma 6.3. All right, so let's write the equation of that one. Here we go. Slope is 6.3. Did you get 0.4? Nod or shake or something? 0.4? So I'll pick a point, I'll use the first one. Y minus 5.9 equals 0.4, x minus 1998. Now, I gotta be careful. Okay, for line, but the directions say, write an equation, linear equation for y in terms of x. So that means I need to get y by itself. Okay, so y equals, so. I got 0.4x. Oh, never mind. Plus, minus 793.3. All right, help me out, is that right? Okay, so here's my equation. Use the equation to predict the spending in 2002. All right, how am I going to do that? I'm going to predict the spending in 2002. So what would I do?
Plug in 2002
For X, because X is years. So just plug in 2002. And did you get 7.5? Yeah, good. Now, we're gonna do that second part here in a second. But use the equation to predict the spending in 2002. So my equation gave me 7.5, but I actually have the data from that year, and it is 7.4. So that's trillions. So 0.1 trillion is still a lot of money, but it's close. Okay, now, what would have happened if instead of using the first 2 points, I used the first and the third? I would have gotten a slightly different equation. Yeah, the equation was different. And that would mean that I would have gotten a slightly different value when I plugged in 2002. What if I used the second and the fifth point? Same thing, right? So we would ideally like to write the very best equation that we could, the closest one to all those points. So we're gonna let our calculator do that. When I was your age, I had to do it by hand, but no longer. Now we get to do it with our calculators, all right? Let's get them out.
This one?
Go to stat. Have you done this before? Regressions, do you know how to do it? So go to stat. Now, I use my calculator, so there are numbers. So when you press, press stat and then edit. Click edit. And when I do that, I already have stuff in there. You may not, depending on if you've ever done this with your calculator or not. So, the easiest way, you can manually clear out all those data points. The easiest thing to do though is simply to use your arrow buttons, go up and highlight L1. So where it says L1, that column, highlight that, press clear and enter. And that will get rid of L1. And then go over and highlight L2. Actually highlight L2, press clear and enter. And now your column should be empty. You are allowed to type in right on top of what's already in there. The problem becomes if you already have 10 data points in and you're only typing in, like that, the last problem had 10, but your new problem only has 5, it's gonna screw things up if you don't get rid of those other extras. So I always just clear everything from the beginning. You don't have to, but that's quick and easy. All right? L1 is your X's, L2 is your Y's. So we're gonna put in our X's and our Y's. And corresponding, so like the first point, X1 is 1998 and the Y1 would be 5.9. Okay, we got them all in. Okay, when you get them all in, after you get the last one in, and you press enter to get that one set, then go ahead and hit second quit. So in other words, we want to get out of that menu. We were in the stat edit menu, and we need to get out of there. So you just hit second quit, and that will just take you back to your home screen. Okay, now go back in. So not second, just stat. And now we're gonna do some math with it. So go over to calc, we're gonna calculate with our data. Edit is where you put the data in. Calc is where you do stuff with it. Okay, now you have lots and lots and lots of options. This problem told me to write the equation of a line. So I am gonna go down to linear regression. That's it. And I'm gonna press enter. Now, for me, so most of you have these newer calculators. You're just gonna click right on down to calculate. I have to do something else. I have to type in L1, comma L2. And it should give you the equation of your line. Did it? What does it say? Y equals what? 0.374, right? X plus or minus 741.909. Now, what does that mean? That means that the equation, we call it the line of best fit, the equation that fits the data most perfectly, nothing's gonna fit it perfectly, but the equation that fits it most perfectly is that one right there. Now, how close is that one to the one we came up with just using the first 2 points? Well, it's not bad. It's not bad. It's off, but it's not too bad. Is that all right? Okay. All right, I'm gonna stop there. I'm not gonna do the scatter plot now because I'm gonna do another example. I have a couple more examples if we can. So let's get to number 12. Mrs. Hastings Smith plans to invest some money. What are possible values of X? Write an equation that describes this. And okay, so this doesn't look like I'm entering data. Alright, so let's do this problem. Number 12, here we go. What are possible values for X? We would call that the domain. What is the domain of this problem? Possible values of X. Well, kids, how much money does she have? 18,000. She's gonna put part of it in at 5%. So how much she has $18,000, how much could she put in at 5%? She could put in all 18,000, right? So we can go all the way up to 18,000. This is an interval. These are my X values. So that's the maximum she could put into her 5% account. What's the minimum she could put into her 5% account? 0. Because I'm not gonna do any there. That's called your domain. If we were gonna graph this, which there's no reason to, but if we were gonna graph that, this would be your X min and your X max in your window. Because when you write an equation, when you just look at the equation, you don't know what the limitations are. So you have to tell the calculator these are the limitations. Okay, so that's the domain. If she invests X dollars at 5%, write an equation that describes the total interest earned in 1 year. Okay? Remember, this is hodgepodge of stuff you already know how to do. How do we do simple interest? I is obviously interest. What's P?
Principal.
And what's principal?
The duration.
What you put in, your investment. That's your interest rate, and that is time. Now for us, time is 1 because it says for 1 year. Right? So what's that look like? Our interest, how much money is she investing? What's our principal? X at 5%. How does that look to everybody? Does that look okay? T is 1. Is that all the money, all the interest that she's gonna earn now? Well, it will be if she invests all 18,000 here, right? But remember, she's putting some in another account. How much is she putting in the other account? Part of it, yep. What would be that value? She put X, well, you could say Y, but then you're gonna have an issue because you have 2 variables in your equation. So stop and think, what do you know about X? It has to be between 0 and 18,000. So think about that for a second. If she put in 10,000, if this is 10,000, how much would she have left to put over here? 8,000. So if she put 12 here, she'd have 6 over here. So if she puts X here, she'll have 18,000 minus X. And that interest is 8%. Is that equation of all right to everybody? Let's clean it up. It's okay, but we can do a little cleaning. So let's do a little cleaning up here. Did you get negative 0.03x plus 1440? Wish you guys would talk to me. I have all this self-doubt. Is that right? Okay. Okay. How much did she invest in each account if the total interest is $1,050? How much did she invest if the total interest is $1,050? What do I do? Yeah. And forward. Each account. So this was the 5%. And then she must have put in 5,000. Okay, 8%.
Wait, didn't you combine them on step B?
What?
Like, did you combine them on step B? Like, how would you know that that's the 5%? Like the 13,000? Oh, yeah, okay, never mind. Yeah, I get it.
It's not wrong. So my original variable X was defined
okay.
as 0.05. So it stays that throughout, it never changes. Okay, we good with that? All right, P4 done, I'm move on to P5. That homework will be due on Monday. P4 due on Monday. And P5 is rather lengthy, but when we finally get done with it, we'll have a little quick review and take a little quiz over that. There are 8 sections altogether, so we'll have a little quiz after the first 5, and then we'll have a kind of a quest at the end of P, and then we'll jump in and start our curriculum. I got the papers all run off and ready to go over there. Can't wait. So here we go. P5. Zero product property, quadratic equation, quadratic formula, discriminant. Okay, vocabulary. What is the zero product property? Does anyone know? You use it all the time. You just may not have given it a name. You remember when you solve an equation, like, let's say that this equation, and you solve it. Or factor, I should say, you factor it. What is the next step? This is the zero product property. What do you do next? Set each one equal to 0. Now, why do you do that? Because if two things multiply to equal 0, what do you automatically know? one or both have to be zero. So that's the zero product property. If AB equals zero, then A is zero, B is zero, or both. It's the property that allows you to say, then X has to be -4 or X equals -1. You do it all the time. The zero product property. The only way two things can multiply to be zero is if at least one of them is zero. What's a quadratic equation?
Y equals x squared.
What?
Y equals x squared.
Well, that is an example of a quadratic, there's no question about it. I am dealing now, not with functions, but just an equation, so one variable. This is a quadratic equation. He's right, quadratic equations have squares. So a quadratic equation is this. And the only caveat is, A can't be zero. Because what happens if A is zero? You don't have a quadratic, you have a line, right? You have a linear equation. I solved my quadratic equation here by factoring. Some of us hate to factor. I don't love factoring myself. So we have, and factoring doesn't always work. Not everything's factorable. So we have this thing called the quadratic formula, right? You know what it is? Say it to me. X equals negative b plus 1 squared root of 2. Can you drive it? That's what all that space is there for. You're looking at the notes and thinking, why should you need all that space? Because we're going to derive the quadratic formula. So you know, it's not just some made-up thing. It actually came from somewhere, right? So write this down. This is our quadratic. We're going to solve this now. Here we go. First thing I would suggest you do is divide everything by A. So we're going to divide everything by A. I am allowed to do that because even though I just erased it, I already stipulated that A can't be 0. So I'm allowed to do this. So now my equation looks like this. Now let's move that sealed rate thing to the other side. And let's complete the square. We talked about this the other day. Who remembers? What do I do to complete the square? I have to take half of that. So half of b over a would be b over 2a. And then I have to square it. So I'm going to write down b squared over 4a squared. Does that look okay? When you complete the square, isn't your goal to make that into this? Isn't that your goal? To make that a square? What square is that? I know it's x, and I know it's plus. Plus what? Exactly, Miss Kress. Good work. B over 2. And over here, I'm going to add these two together, so I need a common denominator. So I have b b squared minus 4ac over 4a squared. Do you see what's happening here? What's the next step? Square root. And when I square root, these go away, right? So I have x plus b over 2a. I can't do anything with the top. Oh, by the way, when you square root, you get the plus or minus on one side or the other. Like x squared equals 9, so x equals plus or minus 3. That's plus or minus that, over the square root of 4a squared, which is 2a. We get x by itself, so we'll subtract this over. And there it is. Every formula you use in math came from somewhere. We aren't going to have time to derive everything, but nobody just sat down and made this stuff up. They're all derived from something, so that's your quadratic formula. What do we mean by the discriminant? Discriminant. Patrick?
B squared minus 4ac.
This guy right here. Not the radical, just the number, b squared minus 4ac. And why is that number, like, why do we care? Why does that have a name and this doesn't? What's important about that? It tells us what kind of answers we're gonna have. Because what happens if I work that out, that discriminant, and it's negative? My answers will be imaginary. What happens if I work it out and it's 0? Then I'm not gonna have 2 answers, I'm only gonna have 1. What happens if I work that out and it's a perfect square, like 16? I'll have 2 answers, but they'll be rational. There won't be a radical in them, they'll be rational. If I work it out and I get 17, there'll be 2 answers, but they will be irrational. I'll have a square root left over in them. Right? All right, get the calculators out, let's solve graphically. We did a little of this the other day. Oh, thank you. Oh, I'm glad you feel better. Hope you feel better, I should say. All right, solve it graphically. Didn't we do this the other day? We forgot. We did? I thought we did. I meant to, I forgot. If I did, if we didn't do this the other day, we need to do it now. Minus this factors. I know you can factor it and solve it that way. No, we're gonna do it graphically because this one is gonna be a little harder. So let's go do the easy one first. Are you getting started? I would use a standard window, so I would zoom 6. And then I'm going to type in my equation, 2x squared minus 3x minus 2, hit graph. And if that's what I do, if I just type this in and hit graph, I am looking for the x-intercepts, right? So I'm not using intersections, I'm actually looking for the x-intercepts. How do I do that again? 0. So second calc 0, left bound, right bound. I got negative 1/2. And then do it again for the other one. And So, you know how to get cubed on your calculator? Use that little button like that, right there, that'll be your cube. Oh, shoot, potentially, this guy could have had 3 answers, because he's a cube, but in reality, he's only going to have 1. Something cool, you may already know this, kind of a big deal actually, and a cubic equation, x cubed, is always gonna have 3 answers. There are going to be 3 answers to every cubic equation everywhere. The issue this time is, only one of those is a real number. The other 2 are imaginary. So we're going to use our calculator to find the real root. And it looks like it is 1.325, is that what you got? All right, we'll pause there, we'll pick up here. We'll finish P5 probably next time, so our quiz will probably be either in, not the next class, either the next one or the next one after that. We've got planning ahead. Okay. Sit down. Okay, now you can stand up.